Okay, you guys, this is what lesson 3 is about, girls. How do you find the area of a sector?
A over 360.
This is A, so it's A over 360 times pi r squared. So to do a sector, it's the area of the circle. Okay, girls, and TJ, and TJ, you take the, guys, we take the area of the circle and we take the fractional part. I'm finding that some of you are struggling with the fractions, so we could review reducing fractions. We want to leave our answer in terms of pi, and most of the test questions are going to be that way as well. So you're going to have to know how to do some stuff with fractions.
Which slider?
This is the very first one.
AV3 Lesson 3.
Yeah, I'm on it.
This is the very first slide. I'll jump to the other ones. Now, you guys, shh. We did the annulus yesterday, and you remember that? Girls, I'm recording this.
It's off.
Pi r big R squared.
This is capital R. That's little r. So it's pi, capital R squared minus pi. Okay, Zach. Shh. Okay. So those are the two things we've done so far. And then what we're going to do now is find a segment. Circumference is equal to pi times the diameter, or 2 pi r. Okay, and I don't know if we'll give you those formulas, but we will give you formulas.
Like annulus, so go.
Okay.
No, that's not hard.
Hey guys. Sydney, TJ, I'll have to have you leave then. I'm trying to get this done.
Why is it always me? I'm just.
How are you going to find this segment, TJ?
You're gonna minus the triangle.
I'm going to draw in this, and I have a sector now, and then I'm going to take away the triangle.
What is it? So what's the equation?
So you're going to start with the sector, which is A over 360 degrees times pi r squared. And then you're going to take away the triangle. 1/2 base times height. The problem solving is going to occur in deciding if you're adding triangles, taking them away, or how you're cutting up the pi, basically. That's the formula for a segment. So now I'm going to skip down on my slides to get down to the examples of those, which is towards the end. And it's starts right there. I think I was off on my other class a little bit, but that's okay. Okay, a segment of a circle is the region between, okay, what's this line called right here? This is a chord. That's a chord. So it's the region between the chord and the what? What's this called? No? Arc. Okay, so to find the area of the segment, you're going to find the area of the sector, which we'll call this angle A. So it's A out of 360 pi r squared. And we're going to subtract off the triangle, which is 1/2 base times height. As you write the formulas down, and this class is pretty good about that, you usually find much more success. And then I can help you because I know what you tried to do. It's just finding the piece of pie and eating the good part of the pie. I don't like the crust particularly, so I'll eat all the pumpkin pie filling and leave the crust. Well, I do too, but that's the idea. Okay, shh. Let's try this problem right here. Okay, you guys, you ready? Curran?
to let go.
I don't have
Okay, so let's write the formula down.
that.
It's A over 360 okay,
Look at this.
arc, A-R-C.
Oh, whoops.
Okay, guys, I want to find the area of the segment. Okay, girls? It's going to be the area of the sector, and we're going to subtract off the triangle. 1/2 base times height. When I write this down, it tells me what numbers I'm looking for. I need to know this arc. I got that. It's 120. Now, some of you can look at 120 and 360 and see the fraction right away. Some of you are looking at the picture and assuming from the diagram rather than using the numbers. You can't do that. And then it's pi, and what's the radius of my circle? 13. So it's 13 squared minus 1/2. And the way this triangle is done, what's the base of my triangle, Zach? No?
44.
It's 24. And the height is 5. And we need to reduce this a little bit. What fraction is 120 over 36? First off, get rid of the zeros. It's 12 out of 36. So it's 1/3. Pi. You guys know what 13 squared is? Curran?
Yeah.
What is it?
13 squared,
169. 14 squared is 196. That's how I remember them. The last two numbers get switched. Okay, guys? What's half of 24? You know what 12 times 5 is? 60. We found the area of the piece of pie, and we subtract off the triangle. Actually, I think I have 3 problems. So I can write 169 over 3 times pi minus 60. I'm going to need that answer in a second. Is that okay? The problem solving is deciding what to do to find the part that you want. Okay, you ready?
why do you have 169 over 3?
Because that's the same as this. And I wrote it again because I'm going to use it again on the next problem. You'll see. That is the normal way.
It only gives you one measurement. So how do you find out?
We'll do it. We'll do the problems. Right now we're going to do this. It does give you everything. Now look at this picture. If this is 240 degrees right here, how big is this arc? 120. This was 1/3 of the circle, so what's the blue part? Now be careful with this. I am going to, okay, so I want first, this is a little, I'm going to show you 2 ways to do this. I could take the whole circle and subtract the segment, which we just had, or I could take this sector, which is 2/3 of the circle, and then do what? No,
And then add base times height.
and then add this triangle, because this was 240.
Yeah.
So I'm going to do it both ways. I like the adding way better. So I'm going to find the sector, the big blue sector, which is 240 over 360. We already know it's 2/3 Cole, times pi r squared. But I'm not going to subtract the triangle. I'm going to add it right now. So it's 1/2 base times height. Question, TJ?
No.
So this we know is 2/3. Because we just did, what's 1/3 from a whole circle? 2/3. And this is pi times 13 squared plus 1/2, and the base is what? Of my triangle? 24, and the height was 5. So this is going to be 2 times 169. I don't know what that is. Pi plus, and we just did that, it's 60. And that's your answer, although you could multiply 2 times 169, and I could do it. Let's do it the other way. There's another way you could do it. You could find the area of the circle and subtract off the segment that we just found, which I think is harder. I think it's easier to look at the sector that I have in yellow and add the triangle in orange. It doesn't matter, it's the same thing. So what is the area of the circle? What? Well, I should double the 169. Okay, guys? Zach, what's the area of the circle? Shouldn't be at all. Zach, what's the area of the circle? It's pi r squared minus the area of the segment. What's the radius of my circle? So it's pi times 13 squared minus the answer from the previous page, because I don't want to do that again. It's right here. I'm going to copy it, and I'll paste it in over here. And then I'm going to drag it.
Oh, that's a quality.
Okay, do I need parentheses when I subtract that? Yes. I do.
What's 169?
It's the same answer. It just looks different. This is 169 pi minus 1/3 of 169 pi plus 60. At least you can see the plus 60.
Yeah.
But this is
I'm wondering.
one at a time. I think the other way is easier.
I still am wondering
What?
how do you figure out how do you do this, but with only one measure?
I'll get there. You have all the measurements. Okay?
But not on here. There's only
Yes, you do. And that's it. That's all my examples. So let's look at your worksheet. And what problem number is this? Are you looking at the white one, TJ? Which problem are you looking at?
8.
Number 8. Okay.
Are they all 7?
Well, you have a radius. This is number 8. That's a special triangle. Yeah, it's a 90-degree angle. They told us that. So this is 90. This is 7. What's that side? TJ?
7.
It's 7.
Yeah.
So I'm not quite sure what you're saying I'm missing. I got a lot of stuff there.
Well, how do you find that?
The height's 7. Okay, so it's the area of the sector minus the area of the triangle. That's the hard part. Do you see that part? I'm going to take the piece of pie here, the whole piece of pie, and subtract off
We should use
that
a
triangle.
better example than pi since we're using circles, so you can't really tell if you're talking about pie or
Cake,
Oh my God.
pizza.
No. We need to talk about
What part of the cake or pizza do we have? Look at that. It's 90 out of what?
360.
Yeah, you know it's 1/4, don't you? Pi r squared. Cole, what's the formula here? Cole?
R squared minus half.
Good, that's 1/4. pi. What's the radius?
The radius is 7.
Minus 1/2. What's the base and height?
Base
7 and 7. No.
That's right.
Nice job, Sid.
So this is 1/4 pi 49 minus 1/2 of 49. Okay, you guys, this bothers you, but I'm going to write it this way anyway. Okay, you guys, listen up. You have problems with fractions. Curran, I'm going to put the 49 over the 4 because that's usually the way we write it. It's 49/4 pi. It's commutative property. I can move them all around. Minus, and then that's 49/2. Cole, enough. Okay. How about on the green worksheet? Do you have questions on some of those?
What's the homework for tomorrow?
The homework is making sure you get all of lesson 3 done on the green one and getting all of these done. A little extra practice. And the segments that I just did is on the quiz tomorrow. So you better make sure you know how to do the segments. Guess? You don't like the fact that I did that like that? That's the same thing. Half of 49 is 49/2. What, Cole? Okay, so let me bring this up. Yes, I want you to. Yes, you're going to have your answers in terms of pi. So now let's get out the homework packet and ask me questions on that. Cole, stop it. Oh, now the formulas
Are down on the bottom.
are on the next. Whoopsie! Now I'm on the right slide again. They're on the last slide. So you guys have time to work, actually. And we did all that. So you have to go to the very last slide. Right there. Okay? There's your formulas that you're going to get on your test. Yeah. You guys see that? Do you see that? Those are your formulas. I wrote them all out. Okay, so I'm going to go to the worksheet, so I can't be on 2 pages at once, unfortunately. Well, you have that on your iPad. Just go down to the last slide. Okay. I will be collecting this packet on Wednesday, yes. Your test is Wednesday. How about number 4? Yeah. Yeah, let's do it. Okay, I want the shaded region, which is right here.
R is
Okay,
the height is 2.
so it's the area of the sector minus the area of the triangle. Now, what part of the circle do we have? I don't want to write 90 over 360. I can, but it's 1/4, isn't it? Is that correct? Pi, radius squared minus 1/2, base times height. A lot of bookkeeping. What's the radius? What's the radius? Sydney, question? Question? So it's times 2 squared. Minus 1/2. What's the base and what's the height? 2 and 2. Can I go ahead and take 1/4 of 2 squared? Because what's 2 squared?
Oh, it's 1.
Yeah, so you just get 1. So it's pi, and this is 4 divided by 2. So it's pi minus 2. Now, on number 5, there's only 2 problems on here. On number 5, my personal preference is to find the area of the sector, which is 3/4 of the circle, and then add the triangle in. It's harder to find the segment and then subtract from the area of the circle. But it doesn't matter. They're both right. I'm prepared to grade it either way. So I do 3/4 of the circle plus 1/2 base times height. How about any of the other ones? Yes. Okay. This little r, that's little r, and this is big R. What's big R? This is the diameter. So this is equal to 9. You can join it.
What?
You can join them. Either behave or you leave. One of the two. Okay, which ones do you want me to do? I did some of these yesterday, I think. You know, I got 2 geometry classes. I don't remember which ones I did. Which ones do you need to see?
What is that? Is that a pizza?
It's a pizza.
It's a pizza pie.
It's on your green sheet.
Yeah, is it?
Okay, so let's do the pizza pot one. Okay, pizza has a radius of 20 feet. I'm going to draw a pizza here. This is 20 feet. And I have a 36-degree arc. First, it says the can of tomato sauce covers 3 square feet. So what do I want to find? The area. There's the circle, which is pi r squared. But what part of the circle do we have? We don't have the whole thing. You have 36 out of what? 360. That's easy.
So it's like 3 out of 36. Which is
No, it's easier than that. Divide by 36, I get 1. Divide by 36, I get...
well. I want to. Oh,
I don't know. So it's pi. The radius is what, 20? Now, I don't have my calculator. So I'm going to write out 20 squared is 20 times 20, because it's not that hard to do. And then I'm going to divide by 10, because I can do that. What happens? 10 goes into 10 once, 10 goes into 20 how many times? 10 into 20 goes how many times? Twice. So the answer here is, multiply that out. 2 times 20, so it's 40 pi.
4 pi.
Well, that's the area. And then what do you have to do? That's how many square feet you've got. And 1 can covers 3 square feet. So what do I have to do with the 3? Multiply by 3 or divide? Divide. Well, I can do a pretty good estimate without a calculator because this is 3.14 and that's 3. So they're pretty close. It's approximately 40. I think it's 42 if you use a calculator. Because that's a little bit bigger than 3. But pretty much it's going to cancel out.
It's like.
It's 42, I think.
It's 41.88.
Okay, but you have to buy, so you have to round it up because you have to have a can for that extra little bit. Unless you've ever been in my position where you're always a little bit short, and then you go, oh, I got to run to the store, so I didn't get enough. And then you have all the extra leftovers. Okay, how about the
For 14, would you also round?
Yes, says to the nearest dollar. How about these problems? Did you try those? Did you try these on the next page? Well, let's do them. No, they're not that hard.
I skipped over.
Oh, there's something very interesting about them. Well, you might not think it's interesting. I thought it was interesting. Well, how do you find the shade region here? What are you going to do? You're going to, if you have a square, if you find the area of the square, what do I not want? I don't want that circle. So it's the area of the square, and I'm going to subtract off the circle. Okay, that's the first question. Does that make sense? Okay, I'm going to take a square here. I'm not going to do a very good circle because I'm not very good at this. And I'm going to draw a circle here. I just want the shaded regions. So I'll try and shade too. Okay, not a great model, but it works. Here's this square. I don't want the middle part. So you know what I'm going to do? I'm going to cut out what? I'm going to cut out the circle. And I'll just have these little corners. And what am I going to do with the circle? I'm going to throw it away. I only want these little scraps here. Why? I don't know. That's nice and sticky. I pick it up. Okay, Sydney, this is all I want. These little scraps, these were here. I'm going to throw that away. So I'm going to take my square, cut out the circle, throw it away, and I'll be left with these nice little edges. That one's not sticky. Darn it, that one is. But I can put them up here. So that's the plan. And you wouldn't see it on the video anyway. Okay, what's the area of the square? How do you find the area of the square? No, square. Side squared, or base times height. Base and height are the same. Minus the area of the circle, which is pi r squared. Okay, what's the side? Look at the picture. 12. What's the radius? Maybe that's where you're stuck. The diameter is 12. Whoops, that's 12. So r is 6. And there's an interesting result when you do this problem, which surprised me. I didn't see it coming. Well, I did after I did B. This is 144 minus 36 pi. Leave your answer in terms of pi. So let's do the next one. So you had to help me out. Tell me where you got stuck. It's still the area of the square minus, oh, but I don't have one circle. How many circles do I have? 4. Area of the circle. My plan, and when you look at my homework, my plan, because I've done all these problems, and they're all posted on Schoology, you should be able to figure out what I did if you can't solve the problem. So this is side squared minus 4 pi r squared. More workspace. So this is 12 squared. Well, I know what that is. That's 144. Minus 4 times pi. And here's the hard part, the radius. This is 12, so this diameter is 6. So this diameter is, no, what? I have to add 3 circles, add up to 12. Is 4, so you can find the radius. And so the radius here is 3. What do you get when you do that? You get 1, it's the same thing. So it's 4 times pi times 9. Well, what do you think?
Combine, you have to combine 4 times 9.
I think it's an interesting problem.
4 times 2.
You're going to get the same thing on all of them, but show me, prove to me that you do.
Oh, that's so simple.
It is, actually.
36 pi.
Because now you're going to have 9 circles, and then you're going to have 4 times 4, 16 circles. So I thought that was interesting. Now, what about the trapezoid problem? Did you try that one? The answer is probably no. I'm not hearing an answer. Here's my trapezoid. It says the height is 15. Okay.
15 meters.
Good enough. And, do we see that color?
Yeah.
Okay. This mid-segment is right here. Can you see that color?
Yeah.
Okay, that's 32. But what you may not realize is what's the area of a trapezoid? The formula. It's 1/2 the sum of the bases times the height. Well, the mid-segment, that 32, is half of the sum of B1 plus B2. So I'll call it the mid-segment M. It's 1/2 of B1 plus B2. It's the average of those bases. So in place of this, I can put in 32, and I know the height's 15, and I don't know what 15 times 32 is, but I could probably figure it out. And that's it. So this is equal to that length of that mid-segment. I don't know if this is the only time you're going to see that, or you'll see it later. You may see it on the ACT. I know you see trapezoids in AP Calc. No, because this is just a little bit of review. Why it's here, I don't know. Are there other ones? Yes. Well, it might be on your final. I don't know what it looks like. Now, I I gave you some examples of R4s. I wrote up a nice little worksheet, and I'm not sure where it is. I'll bring it tomorrow. But I only gave you the standard problems, the regular kind of problems, and then I have challenge problems. But I'll put them up on Schoology if you want me to print out copies of the challenge problems. But those would be like the R4s. So you could take a look at those.
Yes, no.
I can print them up. I just don't want to waste paper for somebody who doesn't want to try them. They're kind of fun problems. But again, it's all problem solving. I think they're fun problems. No, they're circles. Any other ones you want to look at? Did you guys get number 12 okay? Should we do 12?
Legal activity.
144 minus 36 pi. This is going to be 9 circles, but the radius is going to be 2. Well, I thought you said 15. 32 times 15, whatever it is. Okay, so let's go back and do that other problem. You ready? Number 11. No, not 11. Sorry, number 12. Now, I can find the entire washer, but I don't want all of it. But let's start with that, because that's something I know how to do. If I don't know what to do, I'm going to do something. So it's pi capital R squared minus pi little r squared. What's the big radius? 10.
5.
And the little radius is? Okay, so if I don't know what to do, I'm going to do something. Although graded on Marzano, you have to do all of it. But this is 100 pi minus 64 pi. Phoebe, do you have any questions on this one?
No, this is easy. This is simple.
Okay, that's what? 36 pi. But you know what? We don't have all of that. What do we have? We have x out of 360.
I'd say it's 90.
Nope. Can't look at the picture. That's equal to, that's how much we really have. That's right. This number here, x over 360 times the area, is equal to how much the shaded area really is, which is? Yes, 10 pi. And Cole is right. Cole reduced this fraction and said that that was 1/10, which is good. So it's x over 10 times pi equals 10 pi. What happens to the pi's? Cole? They cancel? How do you solve x over 10 equals 10? No, you can't cancel them.
Times it.
Yeah.
Is x equal to 1? Does 1 make sense? No.
X equals 100.
X equals 100. So we're having some issues with the algebra. Knowing to do this and then multiply by the x over 360, that's the problem solving and the geometry. Okay, ready to go back to 5? 5 was it? Okay, I would do this as, this is 3/4 of a circle plus a triangle. Who asked for this one?
I did.
That's how I would do it. I wouldn't find the segment. So it's 3/4 of pi r squared plus 1/2 base times height. I write it out because I don't want to forget a number. Now what's the radius? 8. Well, I'm going to write it this way because guess what? I don't have my calculator handy, so I'm going to, yeah, but I don't want to divide it. I'll show you an easier way to divide it. It's 1/2 and base times height. This is 8 and that's 8, so this is 8 times 8. Okay, so how do I reduce the fractions? 4 goes into 4 once, goes into 8 twice. So I have 3 times 2 times 8 times pi, and I have half of 64, so that's 32. Now, let me get that 1 out of there. I can multiply these three numbers any order I want. I could do 2 times 8, 16 times 3. That's harder. Or I could do 3 times 2, which is 6. And 6 times 8 is 48. That's easier.
48.
How are you going to get better at doing fractions and arithmetic? Don't use your calculator on easy things like that.
Okay. And I forgot that. The I had to say it again. That's why.
Yeah. Is number 8 okay? Did you guys get number 8?
Oh, it was easy.
It was 105 for.
I don't know what it is.
You did it for a while. Yeah.
I did it. Okay. I don't remember because I've got 2 classes.
America.
Okay? So first we did circumference of a circle, then we did area of a circle, and then we made it hard. Then we took fractional parts of circles, we subtracted triangles, we did concentric circles, and found areas trapped between them. The last thing we're going to do is find surface area. That will be trickier because you have to keep track of everything.